So the conversation that we were having with Muglia and Tristan Handy of DBT Labs was, I'll set it up as the following, and Thomas, I'd love to get your thoughts. If you have a CRM, think about applications today, it's all about forms and codifying business processes. You type a bunch of stuff into Salesforce and all the salespeople do it, and this machine generates a forecast. What if you have this new type of data app that pulls data from the transaction system, the e-commerce, the supply chain, the partner ecosystem, et cetera, and then without humans actually comes up with a plan. That's their vision. And Muglia was saying, in order to do that, you need to rethink data architectures and database architectures specifically. You need to get down to the level of how the data is stored on the disk.
What's missing is a layer that understands and can model the semantics of all of this. And if you want to talk about all of the semantics of even data, you need to think about all of the relationships. You need to think about how these things connect together. And unfortunately, there really is no platform today. None of our existing platforms are ultimately sufficient for this. It was interesting. I was just talking to a customer yesterday, a large financial organization that is building out these semantic layers. They're further along than many companies are. And I asked what they're building it on, and it's not surprising they're using combinations of some form of search together with textual-based search together with a document-oriented database. In this case, it was Cosmos, and that really is kind of the state of the art right now. And yet those products were not built for this. They can't manage the complicated relationships that are required. They can't issue the queries that are required. And so a new generation of database needs to be developed. And fortunately, that is happening. The world is developing a new set of relational algorithms that will be able to work with hundreds of different relations. If you look at a SQL database like Snowflake or a BigQuery, you get tens of different joins coming together, and that query is going to take a really long time. Well, fortunately, technology is evolving, and it's possible with new join algorithms, worst case optimal join algorithms, they're called, where you can join hundreds of different relations together and run semantic queries that you simply couldn't run. Now, that technology is nascent, but it's really important, and I think that will be a requirement to have this semantic layer reach its full potential.
What are your thoughts on that?
I'm a database person. I love solving database problems.
I'm waiting for your launch into
Yeah.
this.
So I mean, Snowflake is a database, right? It's a distributed database, and we wanted to crack those codes because multi-region, multi-cloud customers wanted access to their data, and their data is in a variety of forms. All these services that you talked about, and so what I saw as a core principle was cloud object storage. Everyone streams their data to cloud object storage. From there, we said, well, how about we rethink a database architecture, rethink file format so that we can take each one of these services and bring them together, whether distributed or centrally, such that customers can access and get answers, whether it's operational data, whether it's business data, aka search or SQL, complex distributed joins. But we had to rethink the architecture. I like to say we're not a first generation or a second, we're a third generation distributed database on pure cloud object storage. No caching, no SSDs. Why? Because all that availability, the cost of time is a struggle, and cloud object storage, we think, is the answer.
So when you say no caching, so I think about how companies are solving some pretty hairy problems. Take MySQL HeatWave. Everybody thought Oracle was going to just forget about MySQL. Well, they come out with HeatWave, and the way they solve problems, and you see their benchmarks against Amazon, oh, we crush everybody, is they put it all in memory. So you said no caching? You're not getting performance through caching? How is that true? And how are you getting performance?
So 5-6 years ago, right, when you realize that cloud object storage is going to be everywhere and it's going to be a core foundational, if you will, fabric, what would you do? Well, a lot of times the second generation say, we'll take it out of cloud storage, put in SSDs or something and put it into cache. And that adds a lot of time, adds a lot of cost. But I said, what if we could actually make the first read hot? The first read distributed joins and searching. And so what we went out to do was said, we can't cache because that adds time, that adds cost. We have to make cloud object storage high performant, like it feels like a caching SSD. That's where our patents are, that's where our technology is, and we spent many years working towards it. So to me, if you can crack that code, a lot of these issues we're talking about multi-region, multi-cloud, different services. Everybody wants to send their data to the data lake, but then they move it out. We said, keep it right there.